Okay, guys, in this video, we are looking at question 10 of practice exam 2. And here we have a function, and let's call it f of xy, 12xy minus 4x squared y minus xy squared plus 3. Okay, so the first thing we'll do is we'll just fill out all the partial derivatives, and we do that by carefully considering each term. So 12xy with respect to x, 12 and y are numbers, we keep them, and derivative of x is 1, minus 4x squared y. So 4 and y are numbers, derivative of x squared is 2x. So this will become 8xy. Right? So we keep 4, we keep y, and x squared becomes 2x. Then xy squared. Well, derivative of x is 1, but y squared is now a number, so we keep it. So that's what we get here. Okay, so next derivative with respect to y. So for the first part, that's going to be 12x, because that's a number, and derivative of y is 1, minus 4x squared y. Again, y is a number, so 4x squared we keep. And then minus xy squared, x is a number, and derivative of y squared is 2y. Okay, so that's that. Now, let's take the fxx derivative. So we're taking the derivative of this guy with respect to x. Now, remember that we have three terms here, and they're subtracted, so that we have to take the derivative of each term separately. 12y does not have an x. That'll become 0. 8xy will become negative 8y because 8 and y are numbers and derivative of x is 1. And then y squared also doesn't have an x, so that'll disappear, it becomes 0. Now we repeat the same thing, we take this guy, but now we take the derivative with respect to y. 12y is 12. 8xy will be 8x because 8x is a constant multiple, and y squared is 2y. Now, the final derivative, by the way, before we get to the final one, I would always recommend checking to see if the derivative of fy with respect to x gives you the same thing as the previous answer. So take this guy and take the derivative of it with respect to x, because mixed partials must be the same. And you can see that that's 12 minus 8x minus 2y, so we confirm that that's right. Finally, fyy, we take this guy with respect to y, so 12x has no y, that'll be 0. 4x squared has no y, that'll be 0. And 2xy will become negative 2x. Okay, so that's it. So let's see if I can check that part, because I don't want to move on until that's correct. Now, the rest of this I'm just going to do on the scientific calculator. But before I do that, I have to identify the critical points. So they give me a pointer. They actually tell me that origin is one of the critical points. So this is, generally speaking, is a problem with a lot of people. However, what I would do next is let me just get the scientific calculator here. And let me enter all of these derivatives that I just entered here. I'm going to put that in the calculator. So, by the way, also the original function. So I'm going to put the original function because I will need it. Okay, now I'm going to put fx. So in order to type f sub x in Desmos, you type f, then underscore. Underscore is the same button where the minus is, so shift and then minus. Okay, and that'll be the subscript, and then x, and then you put xy. Okay, so I'm just typing that here. Then I do the same thing, f underscore y's, and then xy. So this is 12x minus 4x squared minus 2xy. Now, to type xx, I do the same thing. I do the underscore, which is shift minus, and then xx. And so that'll give me negative 8y. Xy, do the same. Okay, and finally yy, do the same. Now, one other thing that I will need that I am going to type is what is called, because we're going to be using the second derivative test to decide whether it's a local maximum, local minimum, or a saddle point. So you're going to need to define the function d of xy. And the way you do that, if you just take fxx, so I'll just copy paste that here. You multiply that by fyy, so copy paste that here, minus, then fxy, and we square it. So don't forget to square it. So all of this stuff, we're actually going to need to fill out the rest of it. Okay, so hold off with that. We defined all of this. Now let's see if we can find the critical points. So what we do to find critical points, we make the partial with respect to x and partial with respect to y equals 0. And if we find a critical point, that means that both equations should give us 0, not just one. So note that 0, 0 is one of the solutions, because when x equals 0, y equals 0, you do get 0 and 0 on both sides. So 0, 0 would be a possible point, and that's critical point 0, 0. But you have 3 more, so you need to figure that out. Now, look at the first equation. And notice that each term here has a y. So this has a y, this has a y, this has a y, which we can pull out. So we're going to pull that out. So we're going to have 12 minus 8x minus y equals 0. Now here we're going to use something called zero factor property. So zero factor property says that if you multiply two things and the product is 0, that means that one of them has to be 0. So it's either y equals 0, so it's possible that y equals 0, we'll call this case number 1, or it's possible that 12 minus 8x minus y is equal 0, and so we'll call that case number 2. Okay, so let's first deal with the easier case, which is case number 1, and that is that y equals 0. We're going to plug that into this equation, into the second equation, and see what happens. So we've got 12x minus 4x squared, but y is 0, so that term will drop out and equals 0. Now, in order to solve this, we're going to factor it and again use zero factor property. So we look at the terms and we want to factor out the GCF. So 4 is the GCF of 12 and 4, and x is the greatest common factor of x and x squared. So that means from the first term we'll get 3 minus x equals 0. Again, we use zero factor property either for x is equal 0, which will just give me x equals 0, or 3 minus x equals 0, which gives me x equals 3. So that tells me that I have two critical points corresponding to this case. X equals 0, y equals 0, which I already know because they told me that origin is one of the possible critical points, but also x equals 3 and y equals 0. I want to check 0, 0, and I want to check 3, 0. And that's why I defined these partials, fx and fy. I am going to make sure that both of them are 0 at each critical point. So I can see that that's true for 0, 0, okay? And I'm also going to check that for 3, 0. Both of them must be 0. If that doesn't happen, you messed up. You did not do this correctly. Okay, so that's 2, but we need 2 more. So for 2 more, we're going to look at case 2. So here for case 2, I am going to have for case 2, let me do that here. 12 minus 8x minus y equals 0. So that tells me that y, if I solve this for y, I'm going to do this by substitution. If I add y to both sides, I get y equals 12 minus 8x. So I'm going to plug that into the second equation. So this is 12x minus 4x squared minus 2x multiplied by 12 minus 8x, and that's equals 0. So let's distribute that here. We've got 12x minus 4x squared, and then we have minus 24x plus, so this menu popped up out of nowhere. Okay, 24x, and then we have plus 16x squared equals 0. So let's see if we can collect like terms. Okay, so I don't really know what it wants here. Okay, so here we have negative 4x squared plus 16x squared. That's 12x squared. And then we have 12x minus 24x, that's minus 12x equals 0. Now let's solve that by zero factor property. So we're going to pull 12x out. And from here we get x minus, and here we got 1. So that tells me that either 12x equals 0, that means x equals 0, or x minus 1 equals 0, which means x equals 1. So when x equals 0, let's go ahead and remember the connection we had over here. So y was 12 minus 8x. So if x is 0, y is 12. So we found one more critical point. And when x equals 1, y will be 4. Now, to check that, so I actually got 4 different points, which is a lot. Let's see if I can check this because I want to make sure that I get this right. So I want to check and see if my new points 0, 12, is that a critical point? Both fx and fy must be 0. And it looks like they are. And also 1, 4. So let's do that. Okay, that's 0, and also this is 0. Okay, so I know that all of these critical points, all 4 of them are valid. Okay, so let's see if we can put them there. Now, from the smallest x value, I think that should be probably 0, 12. We have also 1, 4, and 3, 0. So I think the next one would be 1, 4, and finally 3, 0 over here. Okay. All right, so I just need to fill out this whole table. So for each point, I am going to find what is f of that point. Okay, so that gives me 3. I'm also going to find fxx at that point. So that gives me 0. And d at that point. And that's negative 144. Okay, I'm going to repeat the same thing for all of my other points. So I've got 0, 12. So I'm just going to change that here. So this is again 3. This is negative 96, negative 144. Now, the next thing I do is change this to 1, 4. Okay, so that's 19, negative 32, 48. And finally, change this to 3, 0. And 3, 0. Okay. So that's 3, 0, negative 144. Now, to classify this, I need second derivative test, which you should have on the formula sheet. So on the formula sheet, it will say, one thing that you need to remember, whenever d is negative, that is a saddle point, and you do not need to look at anything else. So from what I think, this is going to be saddle point, this is going to be saddle point, and this is going to be saddle point. And so the last one I need to classify is where d is positive. This is where I look at fxx. If fxx is negative, that's a maximum. So it's like the opposite. If fxx is positive, that's the minimum. So because it's negative, that will be a maximum. So let me check and see if this is right.